absolute value of 3 minus 2x is 3 minus 2x if 3 minus 2x is greater than or equal to 0. Right here I bring 2x, and I know that this is x less than or equal to 3/2, and I'm done with that. So now this is negative 3 plus 2x for the rest. I don't have to do anything. I just look at this and I reverse it. This is to the left of 3/2 or 3/2. This must be to the right of 3/2. The other one is the absolute value of x plus 3. So it's x plus 3 if x plus 3 is greater than 0 or equal to 0, which is negative 3, or negative x minus 3 for x less than negative 3. So therefore I have, if you'd like to use the chart, there are other methods. Whatever works for you, I'm fine. I think the chart is self-explanatory and it really helps, but not everyone likes it, and I'm fine with that. So negative infinity to infinity, of course I need only these two numbers, nothing else. So I need negative 3 and 3/2. And I read, this can be replaced by 3 minus 2x to the left of 3/2. 3 minus 2x, 3 minus 2x, or negative 3 plus 2x. And to the right-hand side of negative 3 is x plus 3. And to the left-hand side of negative 3 is negative x minus 3. All I have to do is perform the difference. 3 minus 2x plus x plus 3, which gives us negative x plus 6. And then 3 minus 2x minus x minus 3, which gives us negative 3x, because these two go away. And this is negative 3 plus 2x minus x minus 3, which will be x minus 6. So then the absolute value from here, I'm going to have to copy it so I can show it what it is. There are three options. The option negative x plus 6, negative 3x, and x minus 6. If to the left-hand side of negative 3, between negative 3 and 3/2, and to the right-hand side of 3/2. Any questions on this? Any questions? Yes?
So before I switch to the chart, is it exactly solve it? So once you the x plus 3 equals x plus 3 is greater than or equal to negative 3, can you just solve that from there and compile your answers?
It may be possible. I'm not sure. I have to see it. I'm not sure. I have to see what you're doing. So this is greater than, because it's a negative leading coefficient, this will be switched, right? Because you have to bring it here. So it'll be less than or equal to 3/2, and this is greater than 3/2, and this is greater than negative 3 and less than negative 3. So then all this information is summarized in here for simplicity. If this is easier for you, but if it's not easier for you, use another method. I'm fine. But I think it's self-explanatory. It says the absolute value can be replaced by this to the left-hand side of 3/2. I have two intervals, so 3 minus 2x, and then I have one interval to the right-hand side of 3/2. Here, greater than negative 3, I have two intervals. I have to have x plus 3, and to the left I have negative x minus 3. And then I perform the operation that I'm told to perform, which is the difference. This minus this, this minus this, and this minus this. Is that okay? Okay. So we have to move on to section 1.7, which is inequalities. Most of it is a review. Again, allow me to re-emphasize how to study for this class. Allow me to repeat myself. I apologize at the beginning of the class. I will repeat myself over and over. So here is in the syllabus what I would like you to perform. These are the steps, which means you have to read the section, you have to redo the problems we do in class. You have to go to your book and do the examples. You have to select some odd number problems similar to the ones we did in class and check the answer in the back. As many odd number problems. And only then you can say, I think I'm ready now to attempt my homework. Okay? So I said, ask any questions that you, about what you read, about what you have questions on a problem that you worked on. But the starting point is redo each and every problem we do in class as many times as you need till you understand it. If you don't understand it when you try to do your homework, you're going to stumble from the first problem. So that's what I'm highly recommending. Redo the problems we do in class. That's why I post all these for you. So it is very important to build your algebra skills, not say, okay, I'm ready for homework. It's not, it may happen or it may not happen. Most probably may not. It may frustrate you. Okay, so inequalities, we're going to look at linear, quadratic, which we already did one last time, rational, absolute value. With your permission, I'm going to say that linear is done, and I'm not going to go back to it. If you have any difficulties with them, then you'll let me know. So I'm going to go directly to a polynomial or quadratic or polynomial. So I would like to show you that method that I like to use. You don't have to like it. You don't have to use it. So I prefer this. So I'm going to look at 55 on page 80. And that is x cubed minus 4x greater than 0. I'm asking myself what type of inequality is this? And the answer is not quadratic because the degree is 3. But it's polynomial because the degree is 3. In these cases, I have to factor completely, and I have x, and then x squared minus 4 greater than 0. And I will continue factoring x plus 2 and x minus 2. And if you remember, this is part of our agreement on the first day of classes. I will use the same method I used before. I will study the sign. Study the sign of each factor. And I like to do it with a chart. Of course, if that is the best method for you, use it. So x is the variable in the problem and goes from negative infinity to infinity. Then I have x as the first factor, x plus 2 as the next factor, x minus 2 as the last factor. And I will say here the product of all these because I don't have enough room. Now I'm going to ask you which numbers go in the chart. Which numbers do you think go in the chart? Yes, and? Exactly, and nothing else. And they have to be in ascending order. Perfect. Negative 2, 0, and 2. 0 because x is 0 at 0. Negative 2 because x plus 2 is 0 at negative 2. And 2 because x minus 2 is 0 at 2. What will happen to the product in these three cases? How much do I write here, here, and here?
So it's negative.
It must be 0 as long as one of those three factors is 0. A product is 0 when any of those three is 0, correct? Good. So I see again that all these three have a linear slope, positive slope. They're all linear. So I know that this must be the sequence of signs. No questions about it. But if you do have questions, let me know. So I multiply, on the first subinterval, I multiply 3 negatives. What will be the sign of the outcome?
Negative.
I multiply 2 negatives on the next subinterval. What will be the sign of the outcome? And of course, negative here and positive here. Only now I'm ready to ask myself, what am I looking for? Which sign am I looking for? I want this to be greater than 0. What sign should I have? Positive, right? Good. So is this product ever positive? Yes, it's positive here and it's positive here, which means these are the intervals. Since there is no equal symbol, I will not use a bracket anywhere. So the solution is then x in the interval -2, 0, union 2 to infinity. And this is how I solve a polynomial inequality. Any questions on solving the polynomial inequality?
Can you walk through the chart again one more time?
Yes, negative to positive because it's a positive slope.
Right.
Oh, you pick a number and you'll see it's a negative number. Pick a number between this and the 0 and you'll see it's negative. Plug it in. You pick a number between 0 and infinity, plug it in, you'll see it's positive. Whichever you prefer. Any questions? Is this okay? Or you think in terms of the graph. The graph of any of these will look like this. So at some point there's 0, negative, 0, and then positive. But the other method would be just to plug in a number in each interval. Because the 0 is here in this interval and this interval. Because the 0 is here is in this interval and this interval. But they will always have the same. Now, if the slope changes, in other words, if this one has a negative slope, then the numbers, the signs will be reversed, positive and then negative. Because the line will look like this. Okay? Any questions? Okay, so let's look at now. So that was quadratic or polynomial. In this case, we had polynomial. Let's look at a rational inequality. Okay. Let's say 66 on page 80. So 3 divided by x minus 1 minus 4 divided by x greater than or equal to 1. I'm assuming you have never solved a rational inequality before, and that's okay. I don't think that this is a review topic. Okay, so how do I address this? What do you recommend? Of course, it's rational. Perfect. However, I have to have 0 on one side.
So just bring the 1 over.
Perfect. And then find the least common denominator. Very good. Yes, I have to have everything on one side, and then yes, excellent. Good. Can anyone give us the least common denominator? Excellent. Thank you, Jan. Adjustments.
Okay, so x minus 1 and the x minus 1.
Perfect. But I'm going to write it like this for simplicity, of course. Very good. Well done. So now the top. Can anyone give us the top? Yes?
4x minus 4x.
I didn't hear the first.
Negative 4x.
Okay, I just didn't hear it. I'm sorry.
Plus 4.
Very good. Excellent.
Negative 2x. I mean negative x squared
Yes.
plus x.
Excellent. Perfect. Do you all agree with this? Okay. So now next step. How come that no one said, why don't you multiply both sides by x times x minus 1? Nope. No one said, let's multiply both sides by x times x minus 1.
Because it would be an inequality, would it?
No. So for example, this is also an inequality. And I will multiply both sides by 2, and I get x plus 6 less than or equal to 8x. I move x, so I have 7x and 6, so then x greater than or equal to 6 over 7. It's an inequality. If I multiply both sides by 2, then the inequality doesn't change into something else. So then coming back here, how come that no one said, get rid of the denominator and multiply both sides by x times x minus 1 like I did here in a simple linear inequality?
I didn't think about it.
You were right if you didn't think about it, because you're not allowed to. In an inequality, I'm not allowed to multiply by x, or a quantity having x. Why? I don't know if it's positive or negative. I don't know if to switch the symbol of the inequality or not. So make yourselves a note. In an inequality, you cannot multiply both sides by x or x minus 1 or any expression containing x unless you're told whatever you're multiplying is going to be positive, or whatever you're multiplying both sides by, it's going to be negative. Here, there was no ambiguity. Multiplying by 2 does not change the inequality symbol. So I was allowed to do that. But here, I cannot multiply. I'm not allowed to multiply both sides by x or x minus 1. Very good. Good point. So then I see 4x with negative 4x. I see a negative x squared plus 4. And I see an x minus 1. Do we all agree with this step? Okay, assuming I factor S is, I won't. If you remember the two keywords, factor, 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 and simplify, simplify, simplify. I will never work on a problem with an expression with a negative leading coefficient. I will pull out the negative. And I will factor x plus 2, x minus 2, and x minus 1 greater than or equal to 0. Of course, at this stage, I will simplify. Remember the two keywords, simplify and factor, simplify and factor? I will multiply both sides by negative 1. I don't need to put something like this in my chart. So I will multiply both sides by negative 1, and what do I get? Well, the same thing without minus in front, but the sign will, the symbol, the inequality symbol will switch because I multiplied both sides by a negative number. So I'm really solving this inequality now. Yes, you can use the method in the book by just divvying up the real line and with those points and blah, 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 whatever you decide. I prefer this chart. It doesn't take long at all. You can say it's too much writing. Yeah, I would have to agree with that if you say that. But if you use the other method, you may omit the bracket or the parenthesis. So you have pluses and minuses in all situations. Any questions so far till this point? Any questions?
So for
yes?
If it's a rational inequality using your chart, you're including the denominator? Like
all factors. Nothing goes away. Nothing disappears. All factors have to be in the chart. Now, anyone can tell us the x values that we have to put in the chart in case you agree to use it. Negative 2 is the first one. 0, very good, is the next one. Yes? Excellent. Do we all agree with these numbers? Negative 2, 0, 1, and 2. Do we all see where they come from? Yes? These are the zeros of each expression. So I will put a 0 here, I will put a 0 here, I will put a 0 here, and I will put a 0 here. Since all of them have the same sign because they have the same, I made it so that they're all the same, right? By factoring negative 1 and removing it. What is the sequence of signs for all these linear functions?
Negative.
Right. All of them. Very good. Now I have to be careful. What will you tell me to write under negative 2 for the ratio?
Negative.
Under negative 2 for the ratio. 0 indeed. When the numerator of a fraction is 0, without the zeros on what happens, I don't have the limits. I don't have the thresholds. Yes. What happens under 0 for this function? Right, that's it. It cannot be 0. It's undefined. Good. What do I write under 1?
1. Oh no.
It's a positive. No,
What do we know about a fraction?
We can't have 0.
Exactly. It's undefined. So what do we write under 2? Yes. So this is the problem with the other method. You will not know where you put the equal symbol, and in other words, for the inequality for the answer, and where it's undefined. Be careful with the other method. Okay, on the first subinterval, I have 4 negatives, sign, positive. On the second subinterval, I have 3 negatives. On the next subinterval, I have 2 negatives. On the next subinterval, I have 1 negative. And on the last one, I don't have negatives. As you notice, I only count the negatives because the positives don't change anything. Are you with me, everyone? Okay.
can you repeat that?
Which part?
The last part you said.
We only count negatives because the positives don't change any sign. They don't count when it comes to the sign. Good. So only now I look at the question. The question, it's asking me to find what less than or equal to 0. Which sign am I looking for? Negatives. So here and here. So then the solution must be this and this. How do I write it? X in the interval?
Greater than or equal to the bracket.
Bracket, very good.
-2.
-2 comma 0.
Right.
I cannot.
Close.
That's the key. I cannot. What do I use? Correct. Union. See, that other chart with a real line that the book shows, this is a very tricky part. So union what? Yes. Comma?
Right.
Exactly. Exactly. Any questions on this problem?
Why are you using brackets?
The equal symbol tells me that I have to take 0, but I cannot take when it's undefined. I cannot put a bracket when it's undefined.
Next question. What's the brackets and parentheses?
Equal symbol, bracket. Not equal symbol, parenthesis. Yep. Very good. Any questions? It's a lot of work. So let's go back for just 1 second and look. A lot of work. What did we do? I had to move 1. I have to find the least common denominator. I have to have 0 on this side. If I don't have 0 on one side, the chart doesn't work because I'm studying signs. So if I don't have 0 on one side, this chart is useless. If you have here 3, you cannot use the chart. It has to be 0. And the left-hand side has to be a product. So then we found the least common denominator, then we factored, then we combined like terms, we factored the -1. We wanted to get rid of this. It's in the way. We multiply both sides by -1. However, the sign changes. And then we changed the sign, and then we created this chart. Again, use it if you like it. It's not my own. I was taught this way, so I'm not going to take credit for it. And I study the sign of each factor, linear factors. They're all linear factors. They either look like this or like this. They either come from negative, go to positive, or they come from positive, go into negative. All of them go like this. From negative, cross the x-axis and go positive. Negative, cross the x-axis, positive. And then when we finished, we realized we had 1, 2, 3, 4, 5 subintervals. We have to put these marks here, whatever 0 or undefined, because otherwise we will not know where the threshold is. So these symbols are very important, the zeros and the undefined. Okay, one example is not enough. Right, Shane?
I know there's probably like a cheat way. If we graph that and see where like the graph is.
You can, but that will be a little bit more difficult, and you will have difficulties in identifying the vertical asymptotes.
Okay.
We're going to study this function in chapter 3. Yep. It's not an easy or simple situation with rational functions. Never simple. With rationals, they are not user-friendly. Okay, so let's look at absolute value inequalities. Okay, so I'm going to pick one, let's say 82. You can pick another if you want. So 8x plus 3 in absolute value greater than 12. Now, we teach this in the previous course, and this is what I tell my students, and I'm going to tell you too. I don't want you to memorize any of this. There are certain things that we have to memorize, but there is no need here. So here's the idea. I'm trying to find these numbers whose distance from 0 is more than 12. So looking for numbers whose distance from 0 is more than 12. The absolute value is the distance. So, okay, so where will those numbers be? Between negative 12 and 12, or they will be outside?
They're going to be between, you're looking for numbers that are greater than 12, right? So it would be 13 up to infinity.
Or negative 13 to negative infinity, correct. So therefore, these are two possibilities. We have 8x plus 3, exactly what you said, greater than 12, or 8x plus 3 less than negative 12. So keep in mind, we cannot solve this inequality. We don't cross it out like that, I'm making a point. We cannot solve this inequality. We can solve these two, and the solution, and of course this is an OR type of relationship, which means union. So these two we can solve, and the union of these two solutions will be the solution to this one. But we don't know how to solve this one if we cannot convert it into two simple linear inequalities. So here I subtract 3. Yes, Shane, go ahead. And divide by 8. Of course, here I subtract 3 and divide by 8. The solution must have the union. That's the key here, the key word. So x in the interval. And please tell me how to write the solution of this inequality. Yes?
X in the interval,
Yes?
it's going to be 9.
Negative infinity to negative 15/8. Union. Very good. 9 over 8, comma.
Infinity.
Perfect. Excellent. That is the answer.
Is that, sorry, I never seen still before, is that XIN or XIN?
X is a number in the interval blah, blah, blah with the union. I like to write that in front. It's not mandatory, but I like to write it in front. There is another type of inequality, and I'm going to make one up. Like, for example, 2 minus x in absolute value less than or equal to 3. Again, I will not memorize this, but I will ask myself, okay, how do I find numbers whose distance from, or where will I find numbers whose distance from 0 is less than 3?
3 to negative infinity.
It's between?
Between negative 3 and 3.
Very good. So 2 minus x has to be between negative 3 and 3. Distance from 0 less than 3 units. Distance from 0 less than 3 units must be between negative 3 and 3. Cannot be that way. The distance will be bigger.
So can you break it down for me? 'Cause
That's the only way. That's the only way. The distance from 0 less than or equal to 3. So see, these two can never overlap. If this one is to the right and to the left, this one has to be in between. That's the difference between these two.
I'm confused because I think, is it inclusive, meaning it's 3 is included in that?
Yeah, because of the equal symbol. I have the equal symbol.
Okay, so in programming, right, that's what we do for a living, you say less than or equal to negative 3, negative infinity is the correct answer.
But this is not negative 3.
I'm just saying,
Oh, okay.
sorry, I'm saying 3.
Okay.
Less than or equal to 3, negative infinity is the correct answer. right? Because
But there is no need, because then you'll have to intersect those two solutions. There is no need to do that.
Okay.
You can say to the left-hand side of 3 and to the right-hand side of -3, and that's what you're going to come up with. Same thing.
Okay.
That's where they overlap. I don't recommend you separating this one like we have to separate this one. It will be more work, and if you forget to intersect them, you will not get the solution. So what you're saying to me is this. You're saying this, and the intersection is here, and that's not what I'm saying. You're saying less than or equal to 3, and you're saying greater than or equal to -3.
Right.
And I'm saying this from the beginning, because if you forget to intersect, then you will not get the solution.
It's a distance between.
Right.
Okay.
So I have to subtract 2. Very good point. Thank you, Nick. So -5 less than or equal to -x less than or equal to 1. And the final step. Very good. Very good. Divide by -1 or multiply. So this is 5 and this is x and -1. And yes, I have to flip the signs. Very good. But I have to write the solution or read the solution from the smallest to the largest. And I will write x is a number in the interval. Can anyone give us the interval? Yes. To 5. Very good. Any questions?
So we divide by -1 to do this.
It doesn't matter. Division or multiplication by -1 mean the same thing.
Right.
Yes. I have to because the leading coefficient is -1.
Yeah, that's it.
Yes. It's either multiply or divide. I would like to remind you in section 1.8 about the distance between 2 points and the midpoint. So 1.8, coordinate geometry. And let's suppose we have a point here and a point here. Since A is my first point, I'm going to have coordinates x1, comma y1, and x2, comma y2. I would like to determine the distance between A and B. I'm going to call it lowercase d. And I will form a right triangle . And as you told me a few minutes ago about the Pythagorean Theorem, I'm going to call this one leg, and this will be another leg. But I would like to determine the distance, or the measurement of those legs. Can anyone help? So first of all, I'm going to ask you, how much is this right here? The distance between this point and this point. How much? Of course. Thank you so much. Okay, what is the distance between this point and this point? Of course. And then what is the distance between this point or this point and this point? Very good. And of course, this is y2. So then, can anyone give us the distance between this point and this point? Very good. And now the distance between this point and this point? Good. So then, someone will give me the Pythagorean theorem in this triangle. Right triangle, exactly using the sides that we have here. Because I know it's very easy to say c squared equals a squared plus b squared, but which one is what? So that's what I'm interested in. Okay, so I'm ready.
So x is what? 2 plus x1
Yes,
squared
very good,
plus y
very good,
plus
very good, excellent, equals d squared. Perfect. So that's the formula for the distance, line of, or the measure of a line segment between 2 points. However, I don't want d squared. So as we know, we will take the square root from both sides. So then d, and you will normally say, put plus or minus. I can't because it's a distance, just in this case. And then x2 minus x1 squared plus y2 minus y1 squared. Can I simplify this? The answer is never. Okay, let me remind you, that's okay. We learn from our mistakes. I'm hoping that I learned from mine. So this does not equal the square root of 9 plus the square root of 4. Exactly. And this is 3 plus 2. So then 3 plus 2 cannot equal the square root of 13. Right. So the square root of 13 does not equal 3 plus 2. So bottom line is, when we take the square root or any root from a sum of two terms or several terms or a difference of terms, we cannot simplify. This is it. It's fixed. It's carved in stone. Nobody can simplify it.
Now, if it's a product, can you simplify it?
Yes, of course. Product is allowed. Ratio is allowed, but not the sum or difference. Excellent. Good point. Thank you. Okay. So there is also what is called the midpoint. It's the line that is the point that bisects the segment AB into two equal parts, of course, bisect. So that's the midpoint. And we can show that the midpoint has the following coordinates. Easy to remember. The average of x values, x coordinates of those 2 points, endpoints, and the average of y values. So when I say the average of two values, I mean x1 plus x2. And what will be the second coordinate or the y coordinate? Of course. That's it. So now please give me 2 points. Make up 2 ordered pairs so we can move on.
3.
Yes? -4. Okay. And the other one?
6 and 9.
Excellent. Perfect. Given the ordered pairs, we need to determine the distance between them and the midpoint. I'm going to determine the midpoint right here because it's not a big deal. Let's add these 2 up. Let's add these 2 up. That's it. That's the midpoint. Now the distance requires more work. Right? Okay. So I'm going to write the formula. So the distance is the square root of, this is my x1, this is my x2, this is my y1 and my y2. Okay, I'll write the formula first. X2 minus x1 squared plus y2 minus y1 squared. I will write underneath their numbers carefully. So I write 6 and 3. And I write 9 and -4. And then I perform the operations. 6 minus 3. 3 squared. What is 3 squared? 9 plus 9 minus 4. 13. 13 squared, 169. Therefore, the distance equals the square root of 178. I'll try to simplify it into an exact, and then I will approximate it. So 178 is 2 multiplied by 84, right? 16, no, 89. Okay, there's nothing I can do. So it cannot be further simplified, right? So I have 89, that's it. So if I want to approximate it, I will put in the graphing calculator. I have it up here. And I have the square root of 178. I got roughly 13.34, approximately. We will come back to section 1.8 when we talk about coordinate geometry, about conic sections. Section 1.9 is all about graphing calculators. We will use the graphing calculator every time we need it anyway. However, let's look at one problem on page 105. So section 1.9, using the graphing calculator. Because I want you to have an idea of what is happening here. Find the solutions of the inequality or find the solutions of the equation. Please choose. You tell me what you would like to look at. 64. 64. And that is on page 105. So this is the square root of 0.5 x squared plus 1 less than or equal to 2 times the absolute value of x. Okay. This particular problem has to start with some work, algebraic work on our part, because it's basically two different things because of the absolute value. So when the absolute value of x equals x, and when the absolute value of x equals negative x. So two different situations. Situation number one, when x is greater than or equal to 0. This is now carved in stone. The inequality is the square root of 0.5x squared plus 1 less than or equal to 2x. We will try to solve this in this domain. Okay. So there are several options here. I have no idea about the viewing window. I don't know where these, if they even intersect or not. I could do some algebraic work a little bit on the side, and I will say, what happens? I'm not changing the inequality into an equation, but I want to see if these two, left and right, intersect. So for now, I'm going to say, let me solve on my scratch paper if I'm given this on the test. On my scratch paper, I'm doing some algebraic work to see what's happening here. Well, I know how to solve this equation. I reviewed it last time. It's a what type? Careful. Careful. It's a radical. It has a radical, right? It cannot be linear. It cannot be quadratic. It cannot be rational or absolute value. It has a radical, right? How do I solve it? See how important the terminology is, because when I say radical, I say, oh, how do I solve that? Oh, I have to take both sides to a power, right? If I say quadratic, oops, I have to have 0 on one side. If I say linear, they have to separate them. If I have absolute value, then I have to think of two possible options, and so on and so forth. That's what goes through our minds, right? So I will square. So then I get 0.5x squared plus 1 equals 4x squared. I will have to move 0.5 to the other side, and I get 3.5x squared. 3.5x squared equals 1. So then x squared equals 1 over 3.5. So yes, I can say at this point in time that left and right intersect. They intersect on the left and on the right of 0. But look what I have here. Right. So they intersect somewhere very tiny. When I take the square root from 1 over 3.5, square root of 1 divided by 3.5. What do I get? 0.5. Okay? So they intersect approximately at 0.5. This side and this side. Okay, so now let's give it a shot. Okay, perfect. Let me see where I am with time. 43, that's good. Okay, so in y equals, I will put the left-hand side, which is the square root, parentheses. I'm old school. I put parentheses everywhere. They are not needed in all situations anymore. All these sophisticated calculators understand more than, of course, I always do that. Okay, so x squared, 0.5x squared, and then plus 1. Close the parenthesis. And then I want the other side would be 2x. And I'm looking at the graph. I already see what's happening here, but I'm only interested in from 0 to infinity for now. So I can adjust that with the viewing window, and I say don't show me anything else but 0 to infinity, because that's what I'm looking at, and that's my domain for now. So it shows me on the graph now. So it shows me the first function, which is the square root. It shows me the linear function, which is in red. I really like this software because it's easier to see than just a simple calculator with the overhead. So I'm asked to solve, I'll come back 1 second. I'm asked to solve this inequality. So I am asked to find the interval in which this portion of the graph is below this portion of the graph. So the radical, which is in blue, is below the red, which is the linear function. So which territory will I say? And yes, I need to find this intersect, which I already did.
It's 0.5.
Yes, between this kind of approximately 0.5 to infinity. That will be the solution, where blue is below red. So now I can also do this. Go to second and calc. Do you see? Okay, just making sure. And I want to determine the intersect. And the calculator will give me a much better approximation than my roughly 0.5, of course. So I want to choose 5. And I want to, yes, this is the first curve, the blue curve, yes. And that is the red curve, yes. I'll click on enter again. And I don't want to guess, but I could say 1. I'm going to guess this time. And I know it's going to be 0.5 because I did my work. I didn't know. Nick just picked this problem. I had no idea where I was going to get, what I was going to get and where, right? But I had to do a little bit of work by hand to see what's happening here before I even graph it. So I know that that's the intersect. And now I can say for sure that in the interval 0 to infinity, this inequality has a solution. So I will say x in the interval, and I get point, it's less than or equal to, sorry, so I have to use a bracket then, less than or equal to 0.5345, comma, infinity. So the first inequality, when x is greater than 0 and the absolute value is replaced by x, I did my work on the scratch paper, so I know what to expect. So I'm not startled by the graph or the answer. I did my work, and I know that this is what I come up with.
Why do you put the parentheses at the very end instead of the bracket?
Infinity is not a number.
Okay.
For you, infinity may be 4 million. For somebody else, 5 billion. We don't know. Okay, so then I have the second inequality to solve, which is x when in case then I'm only looking at this. And then I have the square root of 0.5 x squared plus 1 less than or equal to negative 2x. Because now when x is less than 0, as we know from 2 weeks ago, the absolute value of x is replaced by negative x. Are you with me, everyone? Okay, perfect. So now I have to solve this inequality. It's okay. So I'll go back to my calculator.
You have to put this on. Inequality.
No. The inequality symbol cannot change. This is carved in stone. I can only replace the absolute value by x or the absolute value by negative x when the domain is the opposite, right? So I have two inequalities. When the absolute value of x is replaced by x in this interval only, and when the absolute value is replaced by negative x in this interval only. I cannot touch this, and I cannot touch this. Very good question. You always help me when you ask questions, always, because maybe I should have said that. The inequality symbol doesn't change, but I didn't think. I only thought that we saw that I'm only replacing this. So no, the inequality, this is carved in stone, 2 is carved in stone, this is carved in stone. What is not carved in stone is the absolute value of x, which can be replaced by or by. Okay, and now we are looking at the second option, okay? So there is no point. Why there is no point in redoing the problem or the equation or my side calculations? Because if this is negative 2x, when I square it, I still get this. So then I will get the other option. I will get the negative 0.5. Because that's when I square both sides, I will not change anything. So then I can go directly to my y equals, and I'm just going to change the second one by inserting the sign negative. And now I change the viewing window, and I want negative 10 to 0. I don't even want to see anything else, because now the interval is only negative infinity to 0, less than 0. So here's the square root, and here's the line. So now I want to determine on the interval negative infinity to 0, where is the blue below the red? So I will say the interval, x in the interval, negative infinity to negative 0.5345 with a bracket. Finally, I'm ready to write the entire solution. What is the entire solution? Combined solution with 1 and 2. So final solution is 1 union 2. Whatever solution I have in number 1 and whatever solution I have in number 2. So final solution is x in the interval. Can anyone dictate the interval, please? So the solution I got from the first possibility, union the solution I got from the second possibility, is what I'm looking for. Any questions?
It's union because it's